Okay, welcome to this video where we're going to be going through a foundation practice paper 2. Now throughout this video I am going to be going pretty quick through these questions. I'm not going to be breaking them down and explaining them as much as I normally would in one of these videos, as this is intended to be used as a last 1 to 2 day revision before your exam. And I know you're going to have lots of revision to do in the process leading up to that, so I'm going to try and make this video as quick as possible. Obviously, if you've been following these videos before, you'll know that I link all of the topics in the description. If you don't, I am just going to show you how you can go about using that and how you can go about using any of these videos. Now, this paper is around about the 80 marks, but as I said, I am going to be going pretty quickly. So before we get started, let's just show you how you can access all of the additional material. So when you're on the channel, if you click into the playlists, you'll see that the playlists are right there ready for you to go into. So if we click into the Edexcel playlist for this exam revision and have a look at what's inside there, you'll see that all of the videos that I've made are right there for you to access. You've got just there every topic on the paper 2 maths exam for foundation and for higher. And obviously there's the ones for paper 3 in there as well. If you keep scrolling down, you've got videos on how to use all of the formulas. You've got videos on some of the hardest topics, if we carry on down for paper 2. And then you've got a whole series of short revision videos based on some of the tricky topics that are on that revision list. So there's everything in there for you to access, so make sure that you know how to use the playlists. If we click into one of these videos as well, we'll click into the Everything on Paper 2 video, you'll see in there all the additional stuff that you can access as well. So let's have a look at the Every Topic on Paper 2 higher revision video. Okay, so when you're on this video, you can click into the description and you can scroll down and find everything you need. You'll see at the top there that you have links to the hardest videos or the hardest topics video. You've got the practice booklets and the revision checklist for you to download there. You've got all the links for all the foundation and higher exams. You've got the entire quick revision series and all the links there, and you've got all my larger revision videos as well that you can go into. If you keep scrolling, you'll see that I've time-stamped every single topic and a full lesson next to each topic as well. So there is literally everything that you could possibly need for your revision. Let's say, for example, you get down to 1 hour and 22 minutes, so you're struggling on circle theorems. You can see that circle theorems is just there, and there's a full lesson next to it, and inside that lesson there's further links for more circle theorems as well. So absolutely everything is there. It's all laid out really nice and clear for you. Obviously you just need to know how to use it, which is why I'm just showing you, hopefully nice and quickly here, how to use these videos. So I hope that's useful and helpful. If it is, don't forget to like, don't forget to comment, don't forget to subscribe. But we've got a lot to get through here, so let's get started. Okay, so starting on this paper. So question 1, we have write 0.9 as a percentage. Now if you don't know that off the top of your head, you can just multiply it by 100 and you can do that in your calculator and you'll see that you get 90%, and that'll work for converting any decimal into a percentage. So question 2, we are going to order positive and negative integers. So for this one here, we're looking for the biggest negatives to start with. So we have negative 10. Then it would be negative 7, and I would advise sort of ticking them off as you go so you don't miss any. Then we have negative 2 and 0. We finished with the negatives there, we've got our 0, and then we've just got 1 and 8 to finish it off. Tick them off as you go, make sure you've put them all down, and there we go, there's that question. Question 3, we have some temperatures and we've got negatives involved. So it says one evening the temperature was negative 7 and it dropped by 5. What's the temperature at midnight? So actually the calculation we're doing here is we're starting on negative 7 and we are taking away 5. So again, you could actually type that into your calculator, but the important thing here is to know we're starting on negative 7 and we're going down by 5. So again, you can actually just type that in. It's not particularly difficult to do there. You get the answer negative 12. So that'd be minus 12 degrees Celsius. Okay, on to question 4. So write down a multiple of 6 that's between 40 and 50. Obviously, I'm going to keep mentioning, because we do have a calculator for this, you could just keep going up in the 6 times table, but I'd hope that you could at least get to 36, then add 6, and you get either 42, or if you add 6 again, you would have 48. Now this question does say write down a multiple, so we don't want to write down both of them, but you could write down either of those numbers. I'm just going to go with 42, so either of those numbers would be fine as an answer for this question. The next one says, here are 4 fractions. Write the fractions in order of size and start with the smallest fraction. Now, in order to do this, there's different ways that you could approach it. What we could do is we could just convert them all into decimals, and that's probably the quickest way. Without a calculator, I'd be looking for a common denominator, but as we have a calculator, I can just type them in. I can just type in 3 divided by 4, which comes out as 0.75. I can type in 5 divided by 7, which is 0.714285, and there's a recurring decimal above the 7 and the 5, so not the nicest one. 19 divided by 25, that comes out as 0.76, I'll write that above. And 11 divided by 15, and that comes out as 0.73 with a recurring decimal above the 3. So they all have a 7 in that first decimal place, so we'll look at the second decimal place. So the smallest second decimal place is that 5 over 7, we've got 0.71, so that's going to be our smallest regardless of how many digits we have. We're just looking for that second decimal place. The next smallest is the 0.73, so that would be 11 over 15. Then we have the 0.75, which is 3 over 4. And then we have the 0.76, which is 19 over 25. So there we go, there is ordering fractions. And again, just taking note, we were only having to look at the second decimal there. It doesn't matter that this number here, for example, had lots of numbers after the 1. We're just looking at that second decimal place because they all had a 7 in the first decimal place. Okay, on to our next one. So a number y is rounded to 2 significant figures and the result is 0.46. Write down the error interval for y. So for this question here, we're thinking about what is in between 0.46 and the decimals either side. So before 0.46 you'd have 0.45 and after 46 you'd have 0.47. So what we're doing is we are looking for the midpoints between them. So between 0.45 and 0.46 you have the number 0.455. And in between 0.46 and 0.7 you've got the number 0.465. And they are our upper and lower bounds. So we just need to write that in as an error interval. So we put y in the middle as it talks about y here, but it doesn't have a letter. You can just put 0.46 in the middle. Both of our arrows point to the left. One of them has an additional symbol on, which we'll look at in just a minute. So we put the smaller number on the left, 0.455, the bigger number on the right, 0.465. And then we just got to think which one of these does actually round to 0.46. So the 0.455 on the left does round to 0.46, so it can be equal to that. The 0.465 though would round to 0.47, so we don't put an equal to symbol on there, so that'd just be our final answer, leaving it with one equal to symbol on that left inequality. And just think that right inequality is literally, they're both pointing to the left, so that equal to symbol goes on the left one. This next question here, there are 14 rows of seats in a cinema and there are 15 seats in each row. A film was shown at the cinema on Saturday and each ticket cost £6.50. The tickets that were sold cost a total of £1,274. How many tickets were not sold? Okay, so not sold. So if we first figure out how many seats there are, so there are 14 rows, 15 seats in each row. So we can do 14 multiplied by 15, and that's going to tell us the total amount of seats. So if we type that into a calculator, that's 210 seats. With these sorts of questions, just label all your numbers so you know what you've actually worked out. So each ticket costs £6.50. So if we were to sell all the tickets, what would that cost? So, I mean, there's lots of different ways we could go about working this out. We could actually just figure out how many we sold from here. So either we've got two methods now. We could do 210 multiplied by £6.50. That'll tell us the total cost if we sold all the seats and then work out the difference. Or we could work out how many seats we sold using this figure here. So I think we'll do it that way. So that would be £1,274 divided by the cost of each ticket, which is £6.50. Obviously we're going to type that into a calculator, so divided by 6.5, and that comes out as 196 seats. So it was definitely probably the easier method there, because now we can see the difference. So I'm going to make sure I write down the working out to show how I get my answer, even if I can do that last little bit in my head. So 210 take away 196 is 14. So there were 14 seats that were not sold, or 14 tickets that were not sold, as we've got 14 empty seats. Okay, on to the next question. We've got a number machine. So it says here is a number machine, and the number machine multiplies by 6 and then adds 7. Find the output when the input is 6. So if we input 6, by the time we've multiplied it by 6, it becomes 36. And then we're going to add 7 to that, so that becomes 43. So my final answer, the output there, would be 43. So for part B, it says find the output when the input is -4. So if the input is -4, again, we would times that by 6. And you can do this all on a calculator. That would become -24. And then we would add 7, which is going to get it closer to 0. It goes to -17. So there we go. We've got -17 for that negative input of 4. And then for part C, it says find the input when the output is 79. So if the output was 79, we'd put that right at the end, and we're going to have to work our way backwards. So if it was 79 here, what was it before we added 7? Well, we can take away 7, which gets us 72. And then what was it before we times by 6? Well, we can divide by 6, and that gives us an answer of 12. So going back through there, we've just done the opposite of the number machine, and we took away 7, going that way as well. So there we go, our input would have to be 12, and you can always test that out as well. Just run it back through the number machine, multiplying it by 6 to get 72, and then adding 7 to get 79. That confirms you've got it correct. Okay, so there we go, there's our number machine. Right, so this question we've got some coordinates. So plot the point with coordinate 3, 2 and label it point A. So 3, 2, I start at the origin, we go across by 3 over to here, and then up to 2, so just there. So that would be our point A, we'll just label that A. Part B, it says write down the coordinates of the midpoint of BC. Now when you're finding a midpoint, if you have the numbers, then you can add them together and halve them. But this one here, it's quite clear to see that the midpoint is just there, right in the middle of that line. But if you weren't sure and it was a little bit more complicated, you could take the x coordinates, so -3 and 1, add them together, which is -2. And again, you can do this on the calculator and divide it by 2. And that gives you -1. And you can see our x coordinate of the midpoint is on -1. So I'm confident enough to do this question by looking at it, but you do have that method as well if it was a bit more complex. So for that one there, that coordinate is -1 on the x-axis, so that would be -1. And then it doesn't go up or down on the y-axis, so that'd be a y coordinate of 0. So -1, 0 is our midpoint. Okay, so that's the end of that question. Alright, so for this question we're using mathematical symbols. So it says write one of these symbols in each box to make the 4 statements true, or 4 true statements. So we have the less than, greater than and equal to symbol. So 14 is less than 21, so we put the less than symbol in there and literally just read it like that. For the next one we've got to do some working out. So 4 plus 7 is 11, and we've got 103 take away -2. And don't forget with these sorts of questions you do have a calculator, so don't waste your time trying to work them out. That comes out as 11 as well. So they are equal to one another, so we put our equal to symbol. 2 squared is 4, and 2 times 2 is also 4, so they're equal as well. Now chances are this one's going to be greater than, but let's just think about that. So -3 and -5, well -3 is closer to 0 than -5, therefore it's a bigger number, so -3 is greater than -5. Right, so there we go, you can see you just got to know your negatives well on that last one there. The rest were just okay, to be fair, working those out, particularly when you've got a calculator. Okay, so expanding a bracket, and we've got factorising as well. So when we're expanding a bracket, we're just going to multiply what's inside by what's on the outside, remembering that if there's the similar letters as well, then the powers would increase as well. So if it was 5m on the outside, then this wouldn't be 10m as the first piece, but it'd be 10m squared. So just a bit to think about there if it was a slightly different question. And then we've got 5 multiplied by the -3, so that's going to be -15. Remember, when you're multiplying by the negative there, just think 5 times 3, which is 15, and then just keep the symbol the same. So 10m minus 15. Factorising, so we're putting it back into brackets, so just think, what do these two things both divide by? Well, they both divide by 3, so 3 would go on the outside of the bracket. 3n divided by 3 is just n, and 12 divided by 3 is 4, so it'd be n plus 4 in the bracket. And you can always re-expand that, you get 3n plus 12 when you expand it, so we know we've got it correct. On to the next question. A map has a scale of 1 centimetre to 14 kilometres. On the map, the distance between Manchester and London is 18.8 centimetres. What's the real distance? Well, every one of those centimetres is 14 kilometres. So we've got 18.8 of them. So we just have to do 18.8. For every one, we get 14 kilometres. So we'll just times that by 14, and we'll do that on the calculator. 18.8 times 14, and that comes out as 263.2. And there we go, there's our final answer, it'd be 263.2 kilometres. Now notice, even on questions like this, that's a very small amount of working out. But notice how I've still made sure I wrote down the working out, not just so that you can see how I'm doing it, but this is how I'd approach it in an exam. Anything you type into the calculator, you need to make sure you write down on the paper. So question 13, we've got 400 grams of raspberries and 300 grams of strawberries cost £7.46, and then 500 grams of strawberries cost £4.10. Work out the total cost of 200 grams of raspberries and 200 grams of strawberries. Well, we want to work out the cost of every 100 grams. You could work out the cost of every 1 gram, but 100 grams should be fine here. So if we start, and we can't work out anything from the first line because there's two different things there, but this second piece here, this 500 grams of strawberries costing £4.10, we can work out something from that. Now if we divide that by 5, that would give us the cost of 100 grams. That's going to help because then we can work out the cost of the other bits that we've been asked for. So if we divide it by 5, we'd also divide the cost by 5. So I'm going to do £4.10, I'll draw it over here. I'm going to divide that by 5. So £4.10 divided by 5 on the calculator comes out as 82p. I'm going to keep that in pounds, 0.82, because everything's in pounds. Now I can use that in the first piece of information. So it said 400 grams of raspberries and 300 grams of strawberries cost £7.46. Well, how much do those, and let's just scroll up and work it out here, how much do these 300 grams cost? We know 100 grams is 82p, so 300 grams will be 3 times that. So that would be 3 times 0.82. If we just times that by 3 on the calculator, because I've still got the old answer there, that comes out as £2.46. So the strawberries in that first line cost £2.46. So actually what we've got now that 400 grams of raspberries will cost £7.46, take away this £2.46. So if we work that out, we've got £7.46, take away £2.46, and that leaves us with £5. So those 400 grams of raspberries, I'll just put 400 grams of ras, is equal to £5. So if we want to know 100 grams, we'd do exactly the same method as we did before, but now we're going to divide by 4. So if we divide that by 4, both sides, we get 100 grams of raspberries is going to equal whatever 5 divided by 4 is, that's £1.25. So there we go, 100 grams of raspberries is £1.25. So we had the original one, which is 100 grams of strawberries is 82p, and 100 grams of raspberries is £1.25. So no matter what we've been asked for now, we're going to be able to work out the cost. So we want 200 grams of raspberries and 200 grams of strawberries. So we want 2 lots of the 82p, and we want 2 lots of the £1.25. That's the 100 grams of each one. So 2 lots of 82p, and again, you can sometimes just do these ones in your head, but I'm going to type them all in. We get £1.64, and for 2 lots of the £1.25, that's going to be £2.50. So we just need to add those both together to get our total cost, and that comes out as £4.14. And there we go, that would be our final answer. So our final answer there, £4.14. So there we go, using some direct proportion, we have worked out the cost of 100 grams of each, applied that to that first line, to get the cost of the 400 grams of raspberries, and then use that to get the cost of 100 grams, and then we're able to get the 200 grams of both in our final steps. So there we go, on to our next question. Here is a list of numbers. Bridget says to work out the median, you find the middle number, so the middle number is 17. So what she's done, she's looked at these numbers, she's crossed off either side, 3 from each side, and found the middle, which is 17. But of course that's wrong, because when you find the median, you have to put the numbers in order first. So what we should have done is done 12, and then 13, 14, 15, 17, 19, 22. So actually the median would be 15. Now we don't need to say that, but it says Bridget's answer is not correct. What is wrong with Bridget's method? So we would say she hasn't put the numbers in order. There we go. Simple as that. Put the numbers in order. Obviously, if you want to do a larger explanation, like I've done, you can do that, and you can just point an arrow up to it to say she should have done it like this if you feel more comfortable doing that. But it's fine for us to just say she hasn't put the numbers in order. Work out the range of the numbers on the list. So the range is the distance between the biggest and smallest. So the biggest is 22, the smallest is 12. So for the range, we'd do 22, take away 12, which gives us a range of 10. And then for the final part here, it says work out the mean of the numbers in the list. So to work out the mean, we want to add all of the numbers together. So I'm going to add them all up. I'm going to use the ones I've done in order. So 12 plus 13 plus 14 plus 15 plus 17 plus 19, and add 22 at the end. And that adds up to 112. So 112 is the total. And we're going to divide that by how many numbers there are. There are 1, 2, 3, 4, 5, 6, 7. So we're going to divide that by 7. We're just going to do that on the calculator. And I get a final answer of 16. And if it comes out as a decimal, that's absolutely fine as well. You just write down all the numbers on your calculator display. Right, so there we go, there's working out some averages. Okay, so we've got some fractions. So to start with, we've got adding fractions. So we need a common denominator. So I'm going to times the left fraction, top and bottom by 5, and the right fraction, top and bottom by 7, just looking at the denominators on each fraction there. So that would make the left fraction become 10 over 35, and it make the right fraction become 7 over 35. So adding those together, we get 17 over 35. That's our final answer. Okay, so you don't need to add together those denominators, you're just saying how many 35ths there are. And there we go, we don't need to simplify it because the question doesn't say we need to, and 17 over 35 doesn't simplify anyway. But remember, when you have a calculator, you can just type the fraction into your calculator and it will simplify it for you. So for part B, we're dividing, so we need to make the first fraction top heavy first, or improper. So big times the bottom is 3, at the top is 5, so we've got 5/3 that we're dividing by 3/4. So we can just do 5/3 multiplied by 4 over 3, and that gives us a final answer of 20 over 9. That's absolutely fine for us to leave our answer like that, as it doesn't say to give it as a mixed number or anything like that. So 20 over 9 is our final answer. On to the next one here. Emily buys a pack of 12 bottles of water. The pack costs £5.64. She sells all 12 bottles for 50p. Work out her percentage profit and give your answer to one decimal place. So it gives you a hint there, this isn't going to be a very nice decimal. So to work this out, first of all, what do these 12 bottles for 50p actually get her in terms of money? Because then we can work out her profit. Now this is in pounds, so I could keep it in pounds or I could convert it all into pence. I'm going to keep it in pounds. So I'm going to write that as 0.50 or 0.5 and then work it out from there. So 12 times 0.5, I'm going to write it as 0.50, and just so we don't forget that is an actual amount of money, and that comes out as £6. There we go, just typing that in on the calculator. So how much profit did she make? Well, she sold them for £6 and she bought them for £5.64. So if we take those away from one another, that's going to tell us her profit. So take those away and you get 36p. There we go, I'm going to keep that in pounds again as well, so 0.36. So I'm going to write next to that profit so I don't forget. So to work out percentage profit, we do the profit over the original cost, and then we just multiply by 100 because that's going to give us a decimal answer and we want the actual percentage. So to type that all in, we've got 0.36, the profit. The original cost was £5.64. So we're basically saying what is 36p as a percentage of or out of £5.64 that she paid. And when we type that in, it doesn't give you a very nice number at all, but let's times by 100. Let's put here that we're going to times by 100 straight away. So we don't have to write this down twice. And we get 6.3829 and lots more decimals. I'm not going to round it, I'm just going to put a few dots here just to show that it keeps on going. But ultimately we're going to round this to 1 decimal place, so I chop it after the 3, and as you can see there's an 8 after the 3, so that becomes 6.4, so that'd be 6.4% profit, and that's our percentage profit to 1 decimal place. Okay, on to our next question. Okay, so we've got a two-way table, so we just need to read the words very carefully, make sure we put them all in the correct place. So we've got 56 clocks in total. There are only red, the clocks are only red, only blue or only black. 32 of the clocks are plastic, 5 of the 14 blue clocks are plastic, and 8 of the 12 red clocks are not plastic. Use this to complete the two-way table. Well, straight away in the first line we've got 56 clocks, so we'll tick that off and we'll put 56 in the total. 32 are plastic, so the total of the plastic is 32, and we'll tick that off, and before we even carry on, we can work out the total that are not plastic. So 56 take away 32 gives us 24. So there we go, we have our totals. 5 of the 14 blue clocks are plastic. Now that's a good one because that tells us 2 bits of information. 5 out of the 14 blue clocks, so it tells us there are 14 blue clocks, and out of them 5 of them are plastic, so 5 just here. So straight away we can actually work out the ones that are not plastic. 14 take away 5 would be 9, and now they add up to 14. And the same information is given to us on the next line. We've got 8 out of the 12 red clocks are not plastic. So that tells us there are 12 red clocks, and 8 of them are not plastic, so not plastic, and then 4 therefore would have to be plastic. So we just need to complete this by working out the black clocks. So to work that out, it doesn't matter which way we go to be fair, we could go the 4 add the 5 on the plastic clocks, that adds up to 9, and it has to add up to 32, so 32 take away 9 would give us 23. And now what you could do is you can add those 3 together, make sure they add up to 32. On the next one, we've got 8, let's just highlight this, we've got 8 and 9, add them on your calculator, gives you 17, we've got to get to 24. So 24 take away 17 gives us an answer of 7, so that has to be 7. And there we go, make sure they add up to 24. Now we can just go downwards, 23 and 7 add up to 30, so that must be a total of 30. But before you finish, just finish this off by checking that these 3 add together to make 56. And they do, so I'm happy with that. That's all added up correctly, we've not missed any information. And there's our two-way table. Okay, so we've got some exchange rates. So 3 companies sell the same type of furniture. The price in London is, and then we've got the price in London, the price in Paris, and the price in New York. And now it's given us 2 exchange rates. So the euro exchange rate, so we can convert the Paris amount into pounds. And we've got the New York exchange rate there, so we can convert that into pounds too. So to work out which company sells it for the lowest price, we want them all in the same currency. So we'll leave the London currency as it is, we'll leave that in pounds. So we'll just convert the other 2. So the price in Paris is 1,980 euros. So to get that back into pounds, remember looking at the exchange rate, the pound number is smaller than the euro number. Okay, they have the same value, but £1 for every €1.34. So we want to make sure this number goes smaller, and we do that by dividing by 1.34. Okay, if you were to multiply by 1.34, you'd get a larger number, which wouldn't make any sense. So you should recognise when your answer doesn't make sense. Now this does give me quite a long number. I get 1,477, which you can already see is cheaper, but we do have 6, 1, and then lots more decimals. So I'm going to keep it to the nearest penny there. Okay, but there's a lot more decimals in the answer, but that's fine. At the moment, we can see it's definitely less. For the next one, we've got the New York number. So we have 2,250, and again we're going to now divide it by the New York exchange rate, and that's going to give us 1.52. So 2250 divided by 1.52, and that comes out as 1,480.52 point and we get just over. So again, there's a lot more decimals, but I've rounded it to the nearest penny. So as you can see, the cheapest here is in Paris. It's 1,000. It's the only one there that's under 1,480. So I do have to make a statement here. I would just have to say Paris is the lowest price. There we go, and that'll be absolutely fine. I don't have to say by how much. I've got my working out all written down to back that up. So that's fine just to make that statement that Paris is the lowest price. Okay, question 19. So we have a graph here. Let's see, it says the graph shows some information about car production in the UK over 8 years. And we can see from the graph that it's been increasing over those years. So for how many of these years was car production more than 1.4 million? Well, 1.4 million is just here. And if we trace across, we can see those years here, 1, 2, 3, 4, 5, they were all above 1.4 million. So our answer for that would be 5. So there we go, that's nice and easy. Let's see what else we've got. So in which 2 years was car production the same? So you just want to see which ones are the same height. So we've got this one here and this one here. So years 5 and 6. So there we go, put that in, 5 and 6. Right, and there we go, and that's the end of that question. That's just interpreting a graph. Okay, so on to our next one. Okay, so we have some laws of indices. So for this first one, m to the power of 3 times m to the power of 4, you're going to add the powers. So that's going to become m to the power of 7. For the next one, we've got indices in brackets. So everything there is to the power of 3. So this is where we multiply the powers, but you've just got to be careful because we're going to multiply all the powers by 3. So that'll become 5 to the power of 3, it become n to the power of 3, and it become p to the power of 9. Now the only one there that we just need to make sure we simplify is the 5. We wouldn't leave that as 5 to the power of 3, so you just type that into your calculator, 5 with your power button, stick a 3 in there, that's 125. So 125 n to the power of 3, p to the power of 9. And for our final one here on laws of indices, we are going to treat the numbers like normal numbers. So 32 divided by 4 gives us 8, and then we're going to subtract the powers. So we have q to the power of 9 and q to the power of 3. Subtracting those would give us q to the power of 6. And on the n there, we've got r to the power of 4 and r to the power of 1. So 4 take away 1 would give us r to the power of 3. And there we go. So we had all our laws of indices there, multiplication, division, and when they're in brackets. Okay, so we have a transformation. Describe fully the single transformation that maps shape A onto shape B. We can see here that this is a reflection. So it's a reflection in this line here. So there are two ways of explaining that one. Let's first make sure we write down reflection. So it's a reflection. There we go, in the line. And actually, before we write that down, we'll just describe this line because there's two ways of writing that. We can either call this the x-axis, which is probably the one I'm going to write down actually, or you could call it the line y equals 0. Any horizontal line going through the y-axis like that, like this one below, you could call that y is equal to -1. So for the x-axis, you can call that y equals 0, but I'm going to call it the x-axis, so it's a reflection in the x. And actually, just get rid of that. There we go, in the x-axis. There we go, and that would be a fine answer. But again, don't forget, different lines you can call different things. So a vertical line through -3, that one would be called x equals -3. Okay, right, so lots of different lines that you could have to reflect in. Of course, you could have to do lots of different transformations. So again, just like all the rest of these topics, I'll link all the transformations in the description for you. Okay, so question 22. We have Natalia pays, and we've got different amounts for two different people. So we have Natalia pays 13,995 for a car. Lauren pays 14,495. So we've got to assume that, okay, the rate of depreciation for Natalia's car is 12%, and the rate of depreciation for Lauren's car is different. Okay, so let's just highlight this. There we go. And for Lauren's car, the rate is 13%. Okay, work out whose car will have the greater value at the end of 3 years. So when we're doing depreciation, we want to take these amounts away from 100% and think about what that would be. So 100% take away 12%, you can type these in on your calculator, is 88%. And as a decimal, that's 0.88. So the decimal 0.88 will reduce it by 12% for us. If we take away 13%, there we go, take away 13%, that is 87%. And the decimal version of that is 0.87. So they're the decimals we're going to use to depreciate these amounts. So Natalia's car would be 13,995 multiplied by 0.88. Now that would do it for 1 year, but we have to do it for 3 years. So you could do that 3 times, or to save yourself a lot of time, you can just put a power of 3, and that will times it by 0.88 for you 3 times. So 13,995 times 0.88 to the power of 3, and that comes out as £9,537.20 to the nearest penny, and that's for Natalia. Then we have to work out Lauren's. So her car started at 14,495. Hers is going down by 13%, so that's the 0.87 that's left over. Again, 3 years, so we'll put a power of 3 to save some time. So 14,495 times 0.87 cubed, and that comes out as £9,545 and 0 pence to the nearest penny. So as you can see there, the car that has the greater value is Lauren's car, only by a small amount. What's that, like 5, 6, 7, 8 pounds, just less than 8 pounds. So it's very, very close, but Lauren's car still has the greater value. Okay, so I'll just write down here, make sure I spell this right, Lauren's car. Okay, Lauren has the greater value car. There we go, and that finishes our depreciation there. We've got a part B, so it says the rate of depreciation assumed for Natalia's car was too low. How does this affect the value of her car at the end of 3 years? Well, if it was too low, let's just have a look, was that Natalia? So if Natalia's was too low, let's imagine that it was higher. So let's imagine it was, I don't know, 20%. Well, if it was 20%, we wouldn't have times by 0.88, we'd have times by 0.8. And if we actually do that, Natalia's car, 13,995 times 0.8 to the power of 3, that comes out as 7,165. So that's obviously made her car's value a lot lower. Obviously I've gone for quite a big percentage there, might have only been 1 or 2% out, but the important part is that the value of the car would have been lower. Okay, so if we just write here, her car will be worth less. There we go, and there is our answer for that. So again, questions like that, it's always helpful just to think of a number, apply it to the question, redo the working out, and then make sure your answer is super confident. Okay, so question 23. On the grid, draw the graph of y equals 2x plus 1 for the values of x from -2 to 3. So for this type of question here, there are lots of different ways to approach it. So what we could do is just draw a little table and substitute these numbers in for x and y, and then plot all the coordinates. So for the x values, we want -2, -1, 0, 1, 2, and 3. So the equation here says to get y, we just do 2x and then add 1. So we just want to double those x values and add 1. So -2 times 2 is -4, and then add 1. And you can just type these in on your calculator. So that comes out as -3. And there's our first coordinate, -2, -3, which is just there. For the next one, 2 times -1 is -2, add 1 is -1. So -1 and again -1. Now as soon as you've done that and you recognise that this is a straight line graph, you can actually just follow a pattern and you can just see that it's moving up by 2 every time. So the next one will be 1, and then 3, and then 5, and then 7. And just plot those very carefully and pay attention to the scale on the axes, because as you can see, the x-axis here has a different scale to the y-axis. So 0, 1, 1, 3. And then you can see as well, it kind of follows a pattern even within the squares. So there you go, you plot all your points, join them up with a nice straight line, and there you go. And make sure when you are plotting a straight line graph like this, that none of the points are sort of, you know, if this point comes out here, you wouldn't want to draw this kind of weird sort of shape that kind of kicks back on itself. Okay, so make sure it does follow that nice straight line. If it doesn't, go back and correct that point. Don't just leave one if it looks out of place. So there we go. There are other methods that you can use as well, like starting on the y-intercept and just following the gradient and doing the pattern that way, but I'm going to stick with this way using a table. Okay, so on to our next question. Okay, so we've got some more transformations. So for this question here, it says rotate the trapezium about the origin, and we're doing 180 degrees, and label it trapezium A. Now I've got better videos on this that I'll link in the description for rotations to show you exactly how to use tracing paper. Remember, you are allowed tracing paper in your exam. So if you're going to do this, I put the tracing paper over the top, covering the origin and the shape, trace the shape, put your pen on the origin there, which is the rotation point, and then spin your tracing paper around 180 degrees. Lift it up nice and carefully and trace it underneath. But I can see here, by following this sort of 180 pattern, that it goes just there. So I'm going to draw it 180 degree rotated, obviously make sure it's nice and neat on the lines, and that is going to go across to there, and there we go, and that would be our shape rotated 180 degrees. Said to label that trapezium A, so I'll label that as A. It then says translate trapezium T. Now we've got to be careful with this because sometimes it asks you to translate the new shape, but this is actually asking us here to translate the original shape. So by the vector -1, -3. So we pick a point. I'm going to pick this one bottom left. -1 means it wants to go 1 across, so across to there. -3 means 3 down, so it goes to here. So that coordinate is going to go just down to there. So I'm going to get rid of those lines. I just need to draw the shape in from the same point. There we go, which is the bottom left. So we go across, across, join it up, and it says to label it trapezium B. And obviously make sure you do all of those with a ruler and a pencil so that you can rub out any mistakes if you need to, but you can leave in any guidelines that you've used. Okay, so like when I did the little jumps across, it's fine to leave them in, you don't have to rub them out. Okay, but obviously so it looks a bit neater on the screen, I'm going to rub them out. Right, so there we go. There is a rotation and a translation. Okay, question 25. So we have calculate the estimate for the mean temperature. Okay, so it says Linda recorded the temperature in degrees Celsius at 9 AM on each of 30 days. And that's quite helpful. It tells us the total there is 30. The table shows the information about her results. Calculate an estimate for the mean. So when working out the estimate for a mean from a table, we're going to use the midpoints. So we're going to say, well, between 10 and 12 is 11, 12 and 14 is 13, 14 and 16, that midpoint is 15, then 17 and then 19. So what we're going to do is we're going to get the total, or an estimated total, by multiplying the midpoint by how many days that temperature occurred. So we'll put a times sign here. So on 3 days it was 11 degrees, so that would be a total of 33 degrees. We've got 8 times 13, don't forget you've got a calculator here, so 104. 14 times 15, that is, which is 210. 4 times 17, which is 68. And 1 times 19, so that's just 19. So we want to add those all together. I'm going to put a plus symbol here. So we have 68 plus and 19. We've got 210, 104, 33. So add those all together, and I've got 434. There we go. And the total frequency, or the total number of days, was 30. That was given to us in the question, but of course you could add them yourself. So to do the working out here, we're just going to do 434, the total of all the temperatures, divided by the total number of days, which is 30. Type that into your calculator, and I get 14.46, and there's lots of sixes, so it's 6 recurring there. So it says to give your answer to 1 decimal place. So if I chop that after the 4, it's a 6 after the line, so that's going to round it up, that'd be 14.5 rather than 14.4. So our final answer there is 14.5. Okay, on to our next question. Okay, so we've got angles to work out. So we've got ABCD as a parallelogram and EDC is a straight line. F is the point on AD, so that BFE is a straight line. There's a lot of information here. Let's just see what we're talking about. So we have a parallelogram here. Okay, we can see that. That's quite obvious. The next thing, EDC is a straight line. So EDC, this one here. Okay, that's good because that just means that these angles here where they meet will add up to 180. Okay, but we'll assume now going forward that that's a straight line as well. F is the point on AD, this one here. So that BFE is a straight line. Okay, so BFE here is a straight line as well. So that just means we've got things like vertically opposite angles going on there and also angles on a straight line as well here. Okay, so the other bits of information are just telling us the angles that are within there. It says show that ABF is 70. So ABF is this angle here. Now it says show that it's 70. So when it says show that it's 70, we basically we just want to ignore that. So just find angle ABF, and as long as it is 70, we will have shown it. Okay, but just forget that it says that until the very end. Give a reason for each stage you're working. Now these questions can always be done in lots of different ways. So I'm just going to go for it and see which method I can go for, but there are other ways of getting your answer, I would imagine, for this question. Now the first thing that stands out to me is if I want to find that angle, I want to look at this triangle here. If I can find the other two angles, so this angle here and this angle here, chances are I'm going to be able to find that angle. So let's have a look. Now I've spotted straight away, I can get that angle there. So that's going to be 35 degrees. Now you can label this on the diagram and point some lines at it with your reasons, or you could write the reasons below. So I'm going to write the reasons below. So the first one here, that is the angle AFB. So AFB is equal to 35 degrees. It was 35, yep. Okay, and the reason for that is because vertically opposite angles are equal. There we go. Opposite angles are equal. There we go. So make sure with that, if you are going to use vertically opposite angles, that you don't just say opposite angles are equal, because it is actually vertically opposite angles. So there we go, there's our first one. Now how about finding this angle here? Well, that's going to be related to the parallelogram. So with this parallelogram, those angles there, opposite angles in a parallelogram, they are equal as well. So you can see why the vertically opposite angles can actually not be good sometimes, because actually now we're using opposite angles but in a parallelogram. So that's going to be 75. Okay, so here we go. So that is the angle FAB or BAF. There we go. So BAF equals 75 degrees. It was 75. Yep, always check back, because opposite angles in a parallelogram are equal. There we go. Opposite angles in a parallelogram are equal. Okay, here we go. We should be able to finish the question now, because those angles within the triangle, we now have two of them, and we know that angles in a triangle add up to 180. So we can add those two together. So 35 plus 75, which is 110. There we go. And take that away from 180. And that gives us 70 degrees. Now that working out there is actually really important, because it did say show that the angle is 70. So we probably want to keep this working out and keep that down in our, let's see, I probably won't be able to move that. So let's just try and get it down here if we can, because that is an important part of our working out there. And that was our final step. So there we go. And that reason there is because angles in a triangle add up to 180. There we go. We are add up to 180 degrees. And there we go, that'll be our final answer. So there we go, we've shown that it's 70. This bit of working out here was the key part that finished off the show that part. So there we go, quite a lot of marks for those questions, so it's well worth making sure you write down the correct reasoning when you are doing these sorts of questions. Okay, so we have a probability tree. So the diagram shows a fair four-sided spinner. You can see on the spinner there's 3 A's and a B. So we're going to spin the spinner twice, complete the probability tree. So on the first spin, we've got the probability of an A or a B. Well, we can see on here that there are 3 A's and only 1 B. So there are 4 different options and 3 of them are an A. So that's going to be 3 out of 4 for an A and 1 out of 4 that it lands on a B. Now the second time we spin it, we're still using the same spinner, so nothing's going to change. So that's still going to be 3 over 4, that's still going to be 1 over 4. That's going to be the same here as well. There we go, and that's completed the tree. Obviously just watch out, because it might be that the second spin is using a different spinner, in which case they would all change. But again, this one, this cluster of branches here would be the same as this one here. So just got to read the question very carefully. Now let's see, we should hopefully have a part B as well. Work out the probability the spinner will land on A on the first spin and B on the second spin. So that route there would be going up A on the first spin and then down B. And when you do that, you just multiply the 2 fractions that you go through. So we go through 3/4 and 1/4. So our working out would just be 3/4 multiplied by 1/4. Timesing the top gives you 3, timesing the bottom, 4 times 4 is 16. So there you go, your answer would be 3 over 16. Obviously just bearing in mind here as well that you do not have to simplify answers, even though 3 over 16 doesn't simplify, but you don't have to simplify your answers with probability. So there we go. Just also bear in mind you could be asked to work out 2 different routes. So maybe it would also say all the probability it lands on B and then on A, and you'd work that one out as well. You'd add your answers together. Okay, so lots that can come up with probability trees. Okay, so this says, here is a diagram showing a rectangle, A, B, C, D, and a circle. So, let's see, BC is a diameter of the circle, so we can see that just there. Calculate the percentage of the area of the rectangle that is shaded. Give your answer correct to 1 decimal place. So to get the percentage that's shaded, we want to know the area of the whole rectangle, and then the area of just the shaded part. Okay, so we're going to highlight that because this is a relatively tricky question. So calculate the percentage of the area of the rectangle that is shaded. So to start with, let's work out the area of the full rectangle. So the area of the rectangle, there we go, and I'll draw a little rectangle just so we don't have to keep writing all the words out. So the area of the rectangle is going to be 16 times 19. And there we go. So we can type that into a calculator, 16 times 19, and that comes out as 304. That's going to be centimetres squared. So let's work out now the shaded part. So to get the shaded part, we would want to work out the area of this semicircle here. We can take that away from the area of the rectangle. So to get the area of that semicircle, what would we do? Well, to get the area of a circle, the area is pi r squared. So it's going to be pi r squared. And then because it's a semicircle, we'll divide it by 2. Okay, so area is pi r squared, and then divide it by 2. So what is the radius of that circle? Well, the radius is going to be half of the diameter. It says here the diameter over on there is 16, so that radius must be 8 centimetres. So we're going to do pi multiplied by 8 squared, the radius squared, and divide our answer by 2. And you can type that in one go on your calculator. So pi times 8 squared divided by 2, and that gives us an answer. It comes out in terms of pi, so on the my calculator screen it says 32 pi. I'll obviously write that as a decimal, but you could leave it in terms of pi, and that comes out as 100.5309649. There we go. So I'm going to keep all the decimals down to start with. So the area of the shaded part is going to be the area of the rectangle, take away the area of the semicircle. So now we're just looking at this sort of shaded part that looks a little bit like that. So to work that out, the overall area is 304. We're going to take away the semicircle, which is 100.5309649. I've left that number on my calculator though, because I knew I was just about to use that. So I'm just going to do 304 minus the answer on my calculator, and that gives me an area of 203.4690351. You could probably get away with not writing so many here. It does only want our answer to 1 decimal place, so we could probably get away with doing 3 or 4 decimal places, but it wasn't too much effort just to write down the last few. Okay, so we've got all the areas that we need. We've got the area of the semicircle, the shaded part, the whole rectangle. Let's just go back to this highlighted line. So calculate the percentage of the area of the rectangle that is shaded. So we want the shaded part over the total. Okay, so the shaded part is 203.4690351 out of the overall area of the rectangle, so out of 304. So on my calculator, I've already got that answer on the top as well. So answer divided by 304, and then that's going to give us the decimal version. We want the percentage, so we're going to times it by 100, and I get 66.9306. A few more decimals, but at this point, I do know it only wants it to one decimal place, so I don't need to write them all down. So I'm going to chop it after the first decimal, and that is 66.9%. So there we go, final answer, 66.9. And there we go. So there is our final answer for that one. Let's have a look. I think this might be our last question. Let's just have a look. Yep, this is our last question. So we have a simultaneous equation. So for a simultaneous equation, obviously different methods that you could use. I always look at the coefficient of y, and in this particular question, they're not the same. So just got to remember this, because I know a lot of people use same signs subtract and different signs add. Now this one here has different signs. So normally we'd add these equations together when the coefficients are the same. So what you don't need to make sure you don't do is you don't look at these and think, oh, well, they're the same. So that's perfect. The signs are different, so we'll add them together, because that's going to go all kinds of wrong. Okay. Actually, if you're looking at the numbers at the front, they have the same signs, so you would actually subtract them. But I'm going to follow the usual method that I do, and that is I'm going to make the coefficients the same. So I've got equation 1 and equation 2, and I'm going to times equation 1 by 4. And that's going to make the 4, or the y, become 4y. So if I do that, I get 12x plus 4y, and that's going to now equal negative 16. The bottom equation I haven't changed, so I'm going to leave that how it is. 3x minus 4y equals 6. Now they have different signs, so I'm going to add them together. So 12x add 3x is 15x. The y's disappear. Negative 16 add 6 is negative 10. So either way, this isn't the nicest of questions, because already you can see that we're going to get a decimal here, or a fraction, depending on how we write our answer. So I need to divide by 15 both sides. I can do this on a calculator, so it's not too bad. But when I divide by 15, I've got to do negative 10 divided by 15. So I'm going to write that as it is, minus 10 over 15. But that does actually simplify, and your calculator will do that for you. It comes out as minus 2/3. So there we go, there's the first part of our answer. X is equal to negative 2/3. Now we just need to find the value of y. So I'm going to use this first equation. I'm going to sub it into equation 1. Normally I'd just write that down. So sub x equals minus 2/3 into equation 1. You can sub it into any of those equations that we've written down. I'm going to put it into that one. So we have 3 lots of minus 2/3, and don't be put off of that, because particularly when you have a calculator, plus y, and that equals negative 4. So all I've done there is I've changed the x for the x value that we've just worked out. I've kept everything else the same. So 3 times negative 2/3, I can just type that into a calculator. So 3 times minus 2 over 3, and that comes out as negative 2. So that's minus 2 plus y equals minus 4. And if you're good with your negatives, you might spot there that that y value is going to have to be negative. But to solve this, I'm going to add 2 to both sides to get rid of that minus 2. So you get y equals negative 2 straight away there. Right, so there we go, there's our y value. So we just need to write those on our dotted lines. We had x was equal to negative 2/3, which you could write as negative 0.6 recurring, but just be very careful. Because if you obviously type this into your calculator and convert it into a decimal, you'll see you get minus 0.6, but sometimes a lot of people miss the little dot above the 6, and that'd be incorrect. So it's best to leave it as a fraction, and y would be negative 2. And there we go, that is the end of our paper, finishing off with simultaneous equations. So there we go. Obviously I've gone through those quite quickly. But don't forget, and as I showed you at the start, you can go into the description and you can find full lessons on all of these topics. They'll be linked there, and I'll put all the timestamps in, obviously, so that you can click through and find anything you need to. So I hope that was useful and helpful. If it was, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.